till now in horizontal circular motion, we have studied only about, we did not see any impact of the change in potential energy because it is all happening on a single table or in a horizontal level. So, but in a vertical circular motion, there will be a motion of this sort. Suppose a simple pendulum is there. So simple pendulum coming from here to here. To here, it is also moving as a part of circular motion. But in banking of roads, we have only seen a horizontal kind of circle, wherein everything is at the same level. But here, there is a change in potential energy if you take some reference level in vertical circular motion. So similarly, there is a change in kinetic energy also, because if it is coming from top to bottom, there is a loss in potential energy that will be converted into kinetic energy. From when it is going from here to top point, there will be a gain in potential energy, which in turn uh, gives you a loss in kinetic energy. So in terms of work and energy theorem. So this topic is included in work energy concept, the circular motion topic. So we will use force equations, which we have studied till now, and also energy equations, which we have studied. So using both the equations, we will try to figure out this concept of vertical circular motion. So now, suppose if I give you a problem, finally I'll give you two important very equations for solving numerous different kinds of standard problems in circular motion. First, we'll try to understand this concept here. Now, if the question is given of this sort, mass of m, this length of the string is L. Now suddenly it has, you took that string to this much angle at a slant. If you keep the string at an angle theta and just leave it without giving any velocity to this ball will slowly start gaining some velocity right here. So that there will be velocity gain here. So now if I ask you what is the tension in the string when the ball is at the bottommost point, you can try out this question. What is the tension in the string? When the ball is at bottommost point possible. You can try this question out. You can try this question. Just
Sir, bottommost point means that in a mean position, no, sir?
that's what mean position.
Okay.
Now, in general, if the same situation is asked for you, what you will say, if just a similar kind of situation, there will be tension upwards, there will be mg downwards, right? Then you will say the tension is equal to mg. Why? Because at that time, this is not having any velocity, just it is at rest. That is why you will say the tension is equal to mg. But now, the t, because the t minus mg is equal to net force is equal to m into acceleration.
Acceleration is 0.
That is why you have given as t is equal to mg in the.
Yes, sir.
But now in this situation, it is actually accelerating. Why? Because it is rotate. It is as a part of circle, right? First thing,
Yes, sir.
if it is a part of circle, there should be centripetal force, right?
Yes, sir.
So centripetal force will be directing towards the center, right? Isn't it?
Yes, sir. Yes, sir.
Now that centripetal force will be provided by this t minus mg. Got it?
Yes, sir.
This t minus mg is equal to m into acceleration of centripetal force towards the center. This force is there. That means that will be the acceleration of the centripetal force. Got it?
Yes, sir.
Now this t minus mg, what is the acceleration of the
So
centripetal?
T is equal to m into a plus g.
I got it. This a will be what? What is the a? Velocity at this point. I'm considering this Vp. mg square by r or not? Because acceleration, centripetal acceleration formula we have already studied in circular motion. V square by r or r omega square. If you would have studied the topic.
Yes, sir. Yes, sir.
Do you remember this? In the first lecture I taught you this. There will
Yes,
be
sir.
two accelerations, AC and
Yes, sir.
AT. So AT will be when speeding up. But AC always exists in a circular motion, which is towards the center, I told you.
Yes, sir.
R omega square into minus R cap, I discussed in that video.
Yes, sir.
So VP squared R. No, but do we know this VP? You don't know, right?
Yes, sir.
But can we get this VP? This radius will be length here. Length of this will be the radius, right?
Yes, sir.
So we need to find out this VP in the given situation. How will you get VP? Because it is just you did not give any energy to it, just you left. And you left it, the ball itself gained velocity due to the loss in potential energy. Got it? So this is a case. Work done by non-conservative is not there because there's no friction here. Work done by external is also not there because that is also zero. Then you have a situation that of in if you would have practiced the problems in work energy, mechanical energy initial is equal to mechanical energy final. You remember?
Final. Yes, sir.
Then mechanical energy initial is what? Ki plus ui is equal to ki.
KF plus UF.
Initial kinetic energy is zero in this level.
Yes, sir.
Yes. Initial potential energy, if I take this as a reference line,
So positive MGH.
this will be H, right? How will
Yes, sir.
this H? If this is L, this will be L cos theta, right?
Yes, sir.
This will be completely L, right?
Yes, sir.
Now this H will become what? Total length minus L cos theta. That is the H you will get, right?
Yes, sir.
That means mg L into 1 minus cos theta is the initial potential energy. Final kinetic energy is half into m into Vp square at this point, bottommost point, plus final potential energy. I consider this potential energy is equal to 0 as reference line. Then this as mgh. Got it?
Yes, sir.
Then will be 0 final. Now the answer is this mvp square is equal to 2mgl into 1 minus cos theta. You will substitute this value in this formula. T minus mg is equal to mvp square by L. So T minus mg is equal to mvp square situation. I'll substitute 2mgl into 1 minus cos theta, which I got from energy equation by mvp square by L. LL gets cancelled. That will be equal to T is equal to mg plus 2mg into 1 minus cos theta. Got it?
Yes, sir.
Here, I want to teach you the most important thing here. Not only this force equation came into picture, but also energy equation also came into picture to make your problem simplified. Just that extra point, energy will come into picture to all the circular motions problems you have solved in this vertical circular motion to make your life a bit more simpler. Got it?
Yes, sir.
Then coming to the some of the standard questions that are possible. Suppose,
Sir, can you scroll up, sir, 1 minute?
okay,
Yes, sir.
so now coming to similar question, I'll try to give you. You can try solving another question. Suppose if the velocity u is less than root 2 gel, because if it is more than root 2 gel, it's more complex. U is given. You consider this u only and take the formula and tell me what is the maximum theta. Okay. This is the maximum it can go. Okay. Because it cannot go beyond this line. Okay. I'm asking you to find out the theta max. Can you? At this point, the velocity given is u. Okay,
Yes, sir.
just try to solve this question. I'll help you out, but just try to approach this.
Sir,
Whatever,
initially it is given u, and when it reaches that point, what is the angle, no, sir?
maximum angle means that means here velocity will become zero, right? Because
Yes, sir.
as some velocity, it will still go further, right?
Yes, sir.
But if its velocity will become zero here, at that time, what is this theta, maximum theta that it can traverse?
Yes, sir.
Just like if you take this as initial
Yes, sir.
0, so then if you consider this as the height it can go,
Yes, sir.
this is completely L, and this
Yes, sir.
L cos theta from the diagram. This will be
Yes, sir.
L into 1 minus cos theta, right?
Yes, sir.
Okay. So by using mechanical energy conservation, because there is no external force, there is no friction. That is
Yes, sir.
half into m into u square, the kinetic energy plus potential is 0, is equal to finally potential energy is kinetic energy is 0 plus potential energy is mgl into 1 minus cos theta. So this will be gets cancelled. Yes, here force is not required in this question actually. 1 minus cos theta is equal to u square by 2 gl, right?
Yes, sir.
Plus cos theta is equal to 1 minus u square by 2 gl, right? So theta is equal to cos inverse of absolutely. Got it?
Yes, sir.
Next, further going ahead,
I got the same, sir.
got it?
Yes,
Good,
sir.
are you understanding?
Sir, understanding, sir. Understanding, sir.
Now we'll go to some of the standard things possible. I'll teach you one thing from the similar question situation. So it is going from here to somewhere here. Okay.
Yes, sir.
Ask you what is the force equation here? Force equation when the ball has traversed an angle theta. Okay. What is the
Yes,
force?
sir.
How will you write the force equation? I'm just giving you a question. You just try it out. Force equation, not energy equation. I understood that you got how to write the energy equation. I'm trying to ask you to figure out the force equation for the
Sir,
along.
what is actually that force equation, sir?
I'll tell you. Forces will write. So tension will be across this.
Yes, sir.
Tension will be along the length of the string.
Yes, sir.
There will be like this. Okay.
Yes, sir.
These are the two forces acting on the ball of mass.
Yes, sir.
But I will try to draw force equation along this line because centripetal force acts along this line itself, right? Because it's a part of circle. It is moving as if it is a part of circle. So
Yes,
centripetal
sir.
force acts towards the center. That is this. This will be the center of this circle. This
Yes, sir.
is the radius. So I want to figure out the force along the length of the string. That force will be, if I take this is theta, this will be theta, right? Because corresponding angles.
Yes, sir.
You see, these two are parallel. This is a single line. They make equal angle with the two. The line makes equal angles with the two lines.
Alternatively vertical angle.
Not this,
Something like.
because it is like see. You see the two lines. Suppose there is single line is there, so
Yes,
this
sir.
will actually make an equal angle with this. This one and this one are equal angles
Yes, sir.
because they both are parallel. So this line will make equal angles with both the lines. Okay.
Yes, sir.
Then this will become mg cos theta. I am resolving it along the along.
Sir, I didn't understand, sir.
If you resolve the vector into two components, This will become r cos theta. Horizontal component. This will become r sin theta. You know this? And there is a destructive if I add result now I'm considering this magnitude as x, this magnitude as y. So this is theta. What is cos theta? Magnitude of r, right?
Yes, sir.
X is equal to what? R. Similarly, theta is equal to y by r, magnitude of r. That is y is equal to what? R sin. Did you get this?
Yes, sir.
Similar concept we have followed in problems also. When there is mg, when we figure out theta here, this forces come as mg cos theta, right?
Yes, sir.
Forces become as mg sin theta, right? You remember?
Yes, sir.
Similar situation. The force along this line will become exactly. This will become mg cos theta. Become mg sin theta. You get this or not?
Yes, sir.
In the vector, we are resolving into two components along this way and one is along this. Both is 90 degrees perpendicular on the result. So this is 90 minus theta. You get this or not? Jagannathan?
Understanding, sir. Understanding, sir.
This is similar to what we have taught in plane. You can go and watch the video. How I explain.
ದುಪ್ಪದ ಕೇಳಿಸ್ತಿದ್ಯಾ ನೀಟಾಗೆ?
ಏನೋ ಬ್ಯಾಕ್ ಗ್ರೌಂಡ್ ಇಂದ ಸೌಂಡ್ ಬರ್ತಾ ಇದ್ಲೆ, ಏನೋ ನಾಯ್ಸ್ ಇದೆ ಬ್ಯಾಕ್ ಗ್ರೌಂಡ್ ಅಲ್ಲಿ.
ನನ್ರಿಂದನಾ ಸರ್ರಿಂದನಾ?
ಗೊತ್ತಿಲ್ಲ.
ಬ್ರೇಕ್ ಆಗ್ತಿದ್ಯಾ ವಾಯ್ಸ್?
ಬ್ಯಾಕ್ ಗ್ರೌಂಡ್ ಅಲ್ಲಿ ಏನೋ ಸೌಂಡ್ ಬರ್ತೈತೆ, ಏನೋ ನಾಯ್ಸ್ ಇದೆ ಬ್ಯಾಕ್ ಗ್ರೌಂಡ್ ಅಲ್ಲಿ.
Nivas, you pause your video. You pause your audio.
Yes, sir. I paused, sir.
Did you understand this? Resolving. A very important concept. Physics, many times you will use this technique. So now, this will become mg cos theta, this will become mg sin theta. Now this mg sin theta is actually the tangential component which actually makes this ball to slow down because the ball is going upwards direction, but this force is in the backward direction, away from it. So this force will make the ball slow it down. Speeding up or slowing down will be done by this mg sin theta, but changing the angle is done by this along the line forces. Now what are the forces along this line? T inwards, mg cos theta outwards. That will be what? T minus mg cos theta is towards the inside, towards the radius, inwards to the radius, towards the center. This will actually provide the centripetal force required. That will be equal to m into Vp square by R. R is here L. This is the force equation to be written. And for how to figure out this Vp, kinetic this using that mechanical energy conservation concept, you can use that work energy concept and apply. But how to get this force equation? Net centripetal force is equal to m into acceleration of the centripetal acceleration, that is Vp square by R. Net centripetal force along the line is what? T towards inside, mg cos theta away. So minus T minus mg cos theta is equal to mvp square by R. Did you get this or not? Both
Yes,
of
sir. Yes, sir.
Understood, sir.
how to resolve this concept already you can go through in vectors or in motion.
Sir, that is, sir, because this T is inside and mg is opposite to that, and that they both are like involved in this circular motion. So we are using that centripetal acceleration.
Both are involved in centripetal acceleration because centripetal acceleration towards the center.
Yes, sir. Understood, sir.
But this mg sin theta क्या कर सकता है? मतलब if you have a question of this sort, this mg sin theta is tangential to the circular motion, isn't it right?
Yes, sir.
What will this mg sin theta will do is provide that AT that you have learned in the first lecture.
Yes, sir.
What it can do is either speed up or slow down.
Yes, sir.
Here it is slowing down. because the ball is going upwards, but the force is downwards. So what will happen is slowly the ball will slow down or not.
Understood, sir.
But while the ball is coming down, the same mg sin theta will actually accelerate the ball and increase the speed of the ball. That is why you
Yes,
will
sir.
maximum speed of the ball here. Got it?
Yes, sir.
Got it? This is another force equation. By using these two equations, this energy equation and force equation, you can solve any typical tough problem in vertical circular motion. Are you clear with the basics?
Yes, sir.
Let us go to some of the standard results in which examiners have asked it thoroughly. One thing is, one standard question, many students will try to remember the result. One standard conclusion is, so what is the string of length L? What is the minimum velocity that is u to be given to this ball so that this ball can complete a complete vertical circular motion? The ball can traverse a complete circular motion. Are you getting this? This ball has to complete a complete circular motion. What is the velocity that should be given to this ball? Got it?
Yes, sir.
That is a standard question. Just try it out. Whatever you know, I will explain. The first thing is, for many students or any common sense, if you apply, generally we should not use common sense, but if we make sure that the ball reaches to this point, it should be ensured, right? Because it has to complete circular motion means first it has to reach here, otherwise it cannot go for a complete ride. If it falls down here itself, what is the point of having a complete circular motion? Got it?
Sir.
So first thing is we should ensure it will go till here. Second thing, it should have a velocity here. Why I am saying it should have a velocity is, if the string, if the velocity becomes 0 here, what will happen to this ball is the ball will fall down, right? Like this. One ball suddenly goes upwards and the velocity becomes 0 means just it will vertically fall down due to gravity. Got it?
Yes, sir. Yes, sir.
It should have a velocity and it should reach that point, maximum point. So even if it has velocity, we'll try to figure out what is that velocity. Then automatically it will complete circular motion, right? Because from here it has gone till here and it is tried to come like this outside, then automatically it will complete circular motion, right? Because it's already got the enough velocity to move in that circle. Got it? You try to do this experiment. So now how to ensure what is the velocity at this point? So if I give velocity u here, I will try to draw the free body diagram here. But the same concept I applying t minus mg cos theta is equal to, because I'm taking that angle is traversing from this vertical point. This from here the angle, that is the same derivation I thought here. Theta I took here. Now the theta is actually what? 180 degrees. So t minus mg cos theta is equal to mb q point I'm considering this one, q square by L. So now what is the theta here? 180 degrees. So, but what is the minimum tension? Suppose I am trying to find out minimum velocity here. If the velocity should be minimum here, that means here also the possible velocity should be minimum, right? Are you getting this? If given velocity is only less, slowly when it is going up, the minimum velocity at the top point will become minimum or not?
Yes, sir.
Now to make this minimum, what values can this mg is fixed? What can be minimized? Only this one is minimized, right? We cannot change this mg. We cannot change this cos theta because that is 180 degrees when it has gone from here to there. So now what can be minimized is only tension, right? Are you getting this or not?
Yes, sir. Sir, we
Yes,
are
sir, getting, sir.
180 degrees, so we can't change that one, sir. And mg is constant. So we are telling that tension only we can change.
The minimization that can happen only in tension, so that we'll have the VQ minimum possible. Okay.
Yes, sir.
The tension minimum value is what? 0, right? We know the tension can be made 0.
Sir, why we need to have this minimum, sir?
Because I asked you what is the minimum velocity should be given to this ball so it can complete circular motion. If you give higher velocity, it is okay. It will anyway move in a circular motion. What is a particular point below which it will fall down? It will not complete. Above which any velocity is welcome to make it complete circle. You see, you try to take a ball.
Understood, sir. Understood.
You just try to give some velocity. If your velocity is not enough, it will not complete. It will not completely go in a circular motion, right?
Yes, sir. That minimum point above that or closer to that, if you give, then it will move.
If you give above that velocity, it can happily go. That is not an
Yes,
issue.
sir.
Minimum,
Understood, sir.
minimum, I am tension to be 0 because tension cannot be negative, because that means tension cannot suddenly start pushing. It can only pull.
Yes.
That is not true.
Yes, sir.
Now, minus into mg into cos theta is what? Cos 180 is minus 1 is equal to mvq square by L. This minus minus plus it will become. Then vq will become what? Root ZL. Got it?
Yes, sir.
This is the minimum velocity it should have here so that it can complete a circular motion. If it does not have, so you can ask me, sir, even if it does not have, what will happen? So it will actually fall down. So is it root ZL?
Fall down, sir.
No, root ZL से थोड़ा ज़्यादा चाहिए because completely tension 0 भी नहीं होना है. मतलब completely it cannot have 0 tension also because 0
Yes,
tension
sir.
will directly fall down. Just 0.00001 something. Even if a bit tension is there, it can complete circular motion. Are you getting? Just I'm trying to find out.
Yes, sir.
Condition. That means you should score 36 marks above 36 marks to pass the exam. That I'm taking 36 as the condition. That means it should be 0.001 something greater than the extra mark.
Yes, sir.
So that I'm trying to find out the limiting point. Tension, if it becomes 0, it will happen. It will fall down. I'm taking just 0 and finding out the velocity. Just the root GL से ज़्यादा हुआ तो हमारा काम हो जाए. Got it?
Yes, sir. Yes, sir.
Now we will use the energy equation here. What is the energy equation? So initial kinetic energy is half into mu square. Initial potential energy is 0. That should be equal to final kinetic potential energy is what? M L into
MG,
cos theta
MG, yes, sir.
minus cos 180 is minus 1, right?
Yes, sir.
Plus half into m into vq square. Got it?
Yes, sir.
But this will become what? 1 minus of minus 1. 2 mgl, right? Right? 1 minus into minus. Are you getting this?
Yes, sir, we are getting.
Simply, otherwise also you can write easily without considering this formula and all. So what is the potential energy is here? 0 here considered. What is the height here? 2L, right?
Yes, sir.
Mg into 2L, right? Right.
Yes, sir.
Again, I got 2 mgl, right? Got
Yes, sir. Yes, sir. Yes, sir.
What is the velocity VQ here? Tell me. VQ will be how much? Root GL. We already found out. 2 mg
Yes, sir. Root G.
half into m into root GL means root GL whole square is GL, right? Is equal to half into m into u square. I'm just copying the equation. Okay.
Yes, sir.
Now this 2 m get cancelled. M get cancelled. This 2, if I send it to the right side, what will happen? U square is equal to 4GL plus GL, right? This 2 and this 2 will get divided, get cancelled. Are you getting?
Understood, sir. Yes, sir. Understood.
Root 5 GL is the answer. That the minimum velocity that is needed for you to it to complete the circular motion, vertical circular motion, is root 5 GL. Are you getting?
Yes, sir. Understood, sir.
Similarly, you can find out what is the minimum velocity for the particle to go till here. Okay. Like that, you
Yes,
can try solving out. You will get some values. You can do it as
Root 3 GL, I think, sir.
root 3 GL because there will be a potential drop here. Now, if easy question comes from here, it will be somewhere on this technique. So if there is root NGL here, velocity, there will be
Yes, sir.
root N minus 2 GL. Root 5 GL is given, here it will be 5 minus 2 GL. Getting it?
Yes, sir.
Here it will be n minus 4 GL. Here it will be n minus 2 GL. Got it?
Yes, sir.
So this n is should be greater than or equal to 5. Greater than 5 is this n is 3 GL. Okay, n is 3. Okay,
Yes, sir.
it cannot go to here. Are you getting? 3 minus 4 is not possible, right?
Yes, sir.
Not possible in the sense it cannot go to negative root. It can go till here. 3 minus 2 is 1 GL. There will be root GL here, velocity, and it will go to some height better than this, and it will stop here. Got it?
Understood, sir.
So you need to understand this n should be greater than or equal to 5. If it is 3 means here it will go till here. It cannot have a complete circular motion. Got it?
Yes, sir.
If it is 6 here, it will be 6 minus 2, 4 here, root 4 GL. This
Yes,
will
sir.
minus will be root 2 GL. If it is 7 here, 7 minus 2 will be root 5 GL. This will be 7 minus 4 will be root 3 GL. So this will be 7 minus 2 will be root 5 GL. Are you getting? If it is greater than 5, it is very easy to solve with these 4 points. Are you getting? Clear?
Yes, sir.
Yes,
It's
sir.
clear, sir.
On this standard conclusions, you will get any kind of circular motion. But if he wants to twist you a bit, you have to use this tension equation, that is force equation, and other one is energy equation. Sometimes only energy equation will do, but these two are the generally most important equation. But you should understand from where the angle is being taken. Here in all the situation, what we do? We have taken this angle from this vertically downward point, okay? T minus mg cos theta. From here we took theta, right? For it to become 180. Got it? From here in the sense, I will try to draw the diagram. From this line we took the angle. Got it?
Yes, sir. Understood, sir.
So this T minus mg cos theta is equal to mv square by L, and mechanical energy conservation. That two equations are very, very important to solve any kind of force equation, tension equation, or any kind of velocity equation in vertical circular motion. That's it for vertical circular motion.
Yes, sir.
You can try solving problems, and any doubts are there, you can approach me.
Yes, sir.
In case instead of string, there is a rod given here. What is it? Thin
Rods.
rod. And there is a mass of Bob M here hanging to the thin rod. Okay. Thin rod. It's not having any mass and all. If it is having mass, that change will happen. In rotational motion, we'll see that. Thin rod, instead of string, they're using just the thin rod. Okay. It is not having
Yes.
a mass like string. So what is the minimum velocity to complete a vertical circular motion? They'll ask.
Yes, sir.
You might answer root 5 GL, right? That is not the correct. Why? Because for a string will become loose and it will fall down, right?
Yes, sir.
Will the rod become loose?
No, sir. It will stand still or something.
So even if it is velocity 0 here also, it is okay. If the rod will go till here, just take 0.00001 some velocity, it will complete a circular motion, right?
Yes, sir.
It doesn't need to have some velocity like root GL.
Yes, sir.
Because string is there, if it loses, velocity becomes 0, that means the string will fall down. But
Yes, sir.
is it a problem for rod?
No, sir.
If you are able to make it just slack through the topmost point, it goes to the topmost point and has even 0.0001 velocity, it automatically completes circular motion, right?
Yes, sir.
That means you don't need to find out the tension zero concept. The answer here will be root 4 GL. That root GL is not required. Got it?
Root 4 GL, sir.
Because here I'll tell you, half into mu square is equal to change potential energy. Just you are making that kinetic energy converted into entirely potential energy. Mg into h, right?
Yes, sir.
What is that h? 2L right here.
Yes,
This
sir.
is L. 2L. So if you see this, mm gets cancelled. U square will become 4GL, right?
Yes, sir.
U will become what? Root 4GL. So examiner might just replace that thin rod, massless thin rod, instead of string, then your answer will become root 4GL, not root 2GL. So then here it will be same root 4GL here. This will be root 2GL here. There will be zero velocity there. Like that you can solve the problems. Got it?
Yes, sir.
Just a kind of variation. If this rod
Yes,
is
sir.
having mass, then we will see that point in rotational motion. Because
Sir, if it has at the topmost point like at 180 degree, it will be like n minus 2, n minus 4. Then it will only do GL. Yes, sir.
no GL in the sense ki if you give root 5 GL, but even if root 4 GL is also given, it will complete a circular motion.
Yes, sir.
Zero velocity will be there. If root 4 GL given in the bottom, then at the topmost point it will have zero velocity.
Yes, sir. In the top, it will be n minus 4 GL. No, sir. So 4 minus 4 is
Zero.
0.
Zero is okay for this rod situation.
Yes, sir.
Examiner might try to confuse you a bit, but if it has mass, we will see that concept in rotational motion. Because
Yes,
the only little bit change what will happen is the mass will not be at this length L. The mass will be at the center of mass, right? The entire mass is meant to be present at the center of mass. This I taught you in extended bodies potential energy concept in work energy.
yes, sir. Yes, sir.
So that means raise in potential energy will not be mg into 2L. The raise in potential energy will be mg into
mgl by 2.
mg L by 2 plus mg L by 2. Mg into L will be the raise in potential energy.
Yes, sir.
Because this is L by 2 and this is L by 2, right?
Yes, sir.
So that is the variation will be a little bit change. Will this solve that problem in rotational motion? Did you understand the variation? The examiner tries to confuse you.
Yes, sir.
Yes,
Understood,
sir.
That is one. Carefully reading the question is important.
Yes.
Mm.